Hello everyone, welcome to Coadep Econs Academy. Today, our lesson is going to be on the derivation of the quotient rule of differentiation. It's going to be interesting and I urge you to stay with me throughout the presentation. In economics, we make extensive use of calculus and it is important that we understand how the rules that we use were derived. We're going to derive the quotient rule using the first principle of differentiation. Those of you who have not gone through my first lesson, I urge you to look out for the derivation of the power rule. You understand why we use the first principle of differentiation. And that will be very fundamental to today's lesson. This is the first principle of differentiation. It says that when we want the derivative of y with respect to x, then it is the limit of h approaching 0 of f of x plus h minus f of x divided by h. Now our duty is that we're going to apply this first principle of differentiation to the function that has been given. The function says that y is equal to g of x divided by y of x. So we see that y is the quotient of two functions, where g of x is the numerator and I of x is the denominator. To be able to apply the first principle of differentiation, we need our f of x. And our f of x is g of x divided by I of x. We also need f of x plus h. How do we get it? We get our f of x plus h by substituting x plus h into the function here. And when we do that, we are going to get f of x plus h is equal to g of x plus h over I of x plus h. As we have our f of x and f of x plus h, the next thing we have to do is to do substitution. We put in the values here. When we do that, we arrive at this point. So this is our f of x plus h, and this side is our f of x. What we have to do next is to simplify. Now, we can simplify by taking a common denominator. So what I will do is that I'll pick this denominator and multiply through here to get this. I'm also going to proceed to pick this denominator and multiply it through this fraction. When I also do that, I have this. So now we see that we have common denominators. And because we have common denominators, we can pick one common denominator and express the whole of the numerator over that. And we will move to this point. So we have a fraction divided by a whole number. When we take this h, let's remember it is h over 1. So the usual thing we can do is that we reciprocate it to get 1 over h to multiply this. And when we do that, the numerator is going to be multiplied by 1, the denominator is going to be multiplied by h. So we have moved to this point. Now, the job is not yet done. We have to move further to do some simplification. We need a way out to be able to factorize out the numerator. And we can do so by picking one factor here and another factor here. Multiply the two to get a common term and then use it to subtract and add so that we can find a way out to factorize. So I'm going to pick I of x and g of x. I'll multiply it to get I of x, g of x as a term. And this term, what I'll do is that I will subtract it and add it. So look at the term shown in blue. I have subtracted j of x, I of x, and at the same time added j of x, I of x. So the whole term from here to here is 0. That means that by doing this, I have not altered the original problem. But doing this gives us the ease to do our factorization. Let's observe something. We see that this term in black and this term in blue have a common factor, which is I of x. Let's factorize it out. When we do that, we have I of x multiplying j of x plus h minus j of x. Let's come to this side. The term in blue here and the term in black here also have a common factor, j of x. Let's factorize it out. When I do that, I have j of x multiplying I of x minus I of x plus h. Now I want the term in the bracket here to appear the same way as the one in bracket here. And the easiest way I can do it is to multiply this j of x by -1 and each of the terms here by -1. By doing so, this will turn to negative, this will also turn to negative, but this will turn to positive. And that can be rewritten as negative j of x into bracket I of x plus h minus I of x. So this is where we are. Now, you can also see that I have taken out the term that was multiplying h. Let's go back and see. This was multiplying h. So I'm taking it out to multiply the whole fraction. And I do so by expressing it as 1 over that term to multiply the whole fraction here. My next duty is to distribute h for the numerator terms. So the first part here in the bracket, I'm going to divide it by h. And the one here too, I'm going to divide it by h. When I do that, I am at this point. Let's observe something. The term here is a derivative from the first principle. Also, the term here is a derivative from the first principle. The term here is the derivative of j with respect to x. Also, the term here is the derivative of I with respect to x. So we can proceed. At this point, what I need to do is that I have to apply the limit of h approaching 0. So wherever I see h, I put 0 there. And by doing that, I move to this point. Now, I of x multiplied by I of x is I of x squared. So our fraction reduces to this. We can also simplify this by picking the whole terms here and dividing it by I of x squared. And when we do that, we move to this point. And what we have obtained is the quotient rule. So when you have y equals j of x divided by I of x, and you are to find its derivative with respect to x, then you can apply this quotient rule. We move on to apply this quotient rule to one problem. So we are given y equals 3x squared over 8x cubed. We want to apply the quotient rule. Let me say this. You can simplify this dividing through by x squared and then applying the power rule. If you know your basis of indices, that can be done. But this time we want to apply the quotient rule because it is not always easy to do simplification and apply the power rule. So there are important occasions you have to apply the quotient rule. Now we need to use this rule. So we need I of x, j of x. So j of x is the numerator. Remember, j of x is always the numerator. I of s is always the denominator. Now we need to also find derivative of j with respect to x. So from the power rule, we multiply this by 2 to get 6. We subtract 1 here, so we have 6x here. We also need the derivative of I with respect to x. And from here, the power rule will tell us that we multiply 8 by 3 to get 24. We subtract 1 here to get 24x squared. So derivative of j with respect to x is 6x, and derivative of I with respect to x is 24x squared. Now we are going to substitute in the values. When we do that, we move to this point. Now our duty is to simplify. So this is where we are. We do subtraction of the numerator. Now we can simplify this. And this is the derivative that we are searching for. If I was moving faster, please pause and go over. But help me to promote my channel by subscribing, liking, and sharing. Thank you for watching.